So I'm Dr. Anasuya, Threse, founder and director of BiniWorld Innovations. And above that, I am one of the volunteer in LF Decentralized Trust India chapter. I lead the Student Society in India chapter, as well as I am the chair for the healthcare special interest group. So I would have met a few of you and we have interacted with many of you and BiniBFT is uh, started from BiniWorld. So that is the name BiniBFT. And why it is why we started developing is BiniWorld is uh, looking for transparency and trustworthiness for day-to-day applications. So there we need a permission public chains, especially our Hyperledger projects are going to be the best ones. And especially in India, the Fabric is the one mostly preferred. But Fabric, we have the scalability issues. And to overcome that, we started working on this BiniBFT few years back. It was actually almost 3 years plus we started working on. And after a year of research and almost 1.5 years after that, we realized with handful of people we cannot take it forward, and we thought, okay, if you are going to come up with a better consensus algorithm, it will be better for everybody. So we made it as a open source. So and BiniBFT was in the year 2023 accepted as one of the first collaborative learning program, the pilot program projects. So over there, we started working on with 6 mentees, and we come up with the initial design. And in the year 2024, I got a very experienced and very enthusiastic mentee, Mr. Raju. He is working as the senior blockchain developer in National NPCI. So, those who don't know about NPCI, so NPCI is the one behind the UPI transfers in India. So they make our lives very easy. We no need to carry our wallets wherever we go. We have to carry just our phones. With our phones, from anywhere to anybody, from a very small denomination to higher amount, in seconds we can transfer the money. So that is what they do. And in their blockchain team, Raju is one of the major person that I can assure, and he has worked in this project. We have actually reworked on the architecture and we have come up with something good. And stage is over to you, Raju. All the best.
Thank you, ma'am. Thank you for that lovely introduction. Yeah, hi guys. So it's a pleasure to meet you all virtually, and good evening and good morning. So this is Raju Owk, senior blockchain developer at NPCI. So most of you guys heard about NPCI, the products that have been by the NPCI. Mainly, you can think of UPI and CBDC, which are CBDC is one of the project from blockchain team where our teammates has been designed. Along with that, coming to my work that I usually do in NPCI, I used to work on concepts of tokenization, scalability, and interoperable systems. So I have my whole full-time experience is in blockchain. Mainly, I used to work with HLF, Hyperledger Fabric, and we have deep dived with the code base of HLF, and we have reworked, and we are working too right now. And we have been designing some interoperable systems, and we have integrated different type blockchains to interoperable systems. So this is my intro. So that's it for my introduction. So when it comes to the project, so BiniBFT, the optimized BFT for Fabric. So thank you, Anasuya ma'am. So she's the mentor who have guided, and we, along with her, we have just designed an anticipated approach for the Fabric. So basically, BiniBFT implementation has been used. I mean, selected for me. So let's start. What's the main meaning of consensus? Let's assume that we have a concept of consensus. So mainly we can say in a dictionary meaning of a consensus is nothing but an agreement. So what's the need of an agreement? Let's assume if two people are doing some transfer. Let's assume if you're a person buying a land, he want to pay some amount. So there will be some agreement between them that I will buy this particular land for some X amount of time, X amount. So basically that agreement is needed. When come to the technology, the consensus mean agreement that the two systems will come into an agreement that so this transaction is a successful. Let's assume if you are making some X amount of rupees as a transfer, we need to have an agreement that that amount is reliable and two parties has been agreed. So the main theme of consensus is this, and we have different characteristics for consensus. It's not any characteristics, but it's a meaning of a consensus, we can say. So a consensus ensures the system remain functional even some nodes fails or act malicious. Basically consensus will take care of the agreements even in case of a node failure or acts malicious, and it prevents the malicious actor from altering the blockchain history. Basically the consensus concepts plays an important role in blockchain technology. So you might have seen Bitcoin, Ethereum, and HLF with the different blockchain consensus algorithm has been designed: proof of work, proof of stake, and Raft, which is a crash fault tolerance, which has been integrated in HLF. And along with this, enable decentralized node to reach an agreement without a central authority. Basically a blockchain means that different nodes, a decentralized nodes usually come into an agreement without any central authority. So there is a need of consensus which comes without any intervention of a central authority. So we come into an agreement with the help of consensus. That's the main use of consensus in the blockchain stack. And it provides security, finality, and fault tolerance. Basically, it can provide all these things. And you might have known, most of the people have been seeing how Fabric has been there, and it's come up with the Raft initially. Thereafter, we used to have Solo. Thereafter, the present BFT, that is running 3.0 in Fabric 3.0, we have Smart BFT, which is a Byzantine fault tolerance. When it comes to 2 points change of Fabric, where we used to have crash fault tolerance, nothing but Raft. So, but there we have the lacking of Byzantine fault tolerance. But thanks for the team who has designed the Smart BFT, which has been integrated in Fabric 3.0. So the main use of consensus is this. Let's see the next slide. So let's see what's the project overview and the main goal of this project. So how we have approached and what's the theme of this BiniBFT. So basically we are designing a consensus library like of a smart BFT for the Hyperledger Fabric. We are focusing mainly on Hyperledger Fabric for now. And the benefits then comes to consensus library that it can provide end-to-end security, high throughput with low latency and high scalability. These are the benefits that we can see in with the help of this consensus algorithm that we're gonna build. The impact. So basically, the main system, the blockchain is suffering from scalability. Scalability is the main thing, and the high throughput. So we can think these are the two things that has been lagging blockchain. So there are a number of blockchains came into the picture. Let's assume Bitcoin came into the picture. Let's assume Ethereum came into the picture. Solana also ruling now with the high TPS, which are permissionless blockchain, basically public blockchains. Now we have HLF. HLF also having been have that 1000 TPS at most, as per my knowledge. And so for a decentralized application to build for a huge scale, we need a better consensus so that we can able to grow that particular application endless. Let's take an example that a product developed by NPCI, that is UPI. You can see there we can able to see the TPS, a fraction of second you can able to make the payment to one person to another person. The same way we need to have a decentralized system where we can able to make a transfer or asset transfer or else amount transfer, token transfer within a few fraction of seconds, which give a resilient experience for a user. So that's the project overview. So let me tell you why this BiniBFT, as Anasuya mentioned, that the Bini is comes from the BiniWorld, the company owned by Anasuya. So a BiniBFT is also is one of the Byzantine fault tolerance algorithm that has been gonna design. Firstly, let's know about what's the Byzantine fault tolerance. Let's assume there are two things. So one is crash fault tolerance, one is Byzantine fault tolerance. A crash fault tolerance nothing but RAF system, which usually works as a crash fault tolerance. A Byzantine fault tolerance means that let's assume there are four nodes in a network, in a blockchain network, and if there is one node who is malicious, so the system should have that resilience to continue the transaction or to continue the functionality without breaking that particular transaction happening. This is nothing but so Byzantine means, so we can say that the system need to be very resilient. Even though the malicious actor is acting and trying to change the value of a particular transaction, the Byzantine consensus algorithm need to avoid that and need to make a proper transaction flow. So that's the main meaning of a Byzantine fault tolerance. So here the BiniBFT is one of the Byzantine fault tolerance, like of a smart BFT or else mere BFT, that an inspiration for this BiniBFT. Here, it can ensure the agreement even with malicious notes and false notes, like of the normal BFTs that has been there. High resilience against Byzantine failures. I already told you that the system need to be very resilient for a Byzantine failures. Why? Because as we are scaling up to a number of users, there will be a chance of a malicious node came into the picture who will want to make some change, which should not happen. So the system need to be in a such a way that a system need to have that need to tackle the things and need to make that particular transaction successful, even though a person or a malicious node is trying to make it happen. And here in the BiniBFT, we have efficient message propagation with the way the approach that we're gonna think and we are gonna design has been designed. So basically, we think of the BiniBFT for permission blockchain, mainly for HLF. So that's the overall theme of BiniBFT. And so let's assume why. So we come to the question called why. Why BiniBFT for Hyperledger Fabric? Why already existing Smart BFT is there, which has been integrated with 3.2 and it is running successfully. And we are also using it. So presently, I have gone through that implementations of Smart BFT and it's under good work, and it is so good, damn good. But the own main thing why, so they will come to a question why BiniBFT for Hyperledger Fabric. So I will explain you why question. So firstly, Hyperledger previously works with the help of a crash fault tolerance, as I mentioned, which is Raft, which don't have this BFT basically, the Byzantine fault tolerance. But Smart BFT comes along with the Byzantine fault tolerance. So previously, Raft cannot tolerate the malicious node, whereas BFT can. So here the BiniBFT can able to do that, like of Smart BFT. Here, BiniBFT main focus is on enterprise blockchain application with high scalability, high throughput. So that was the main theme of BiniBFT for Hyperledger Fabric, a permissioned blockchain can able to scale more than existing BFTs. We anticipate that we can able to scale more than existing BFTs, and we are specially designing this particular consensus algorithm only for Fabric for now. So later on, we'll think of the rest of the blockchains. For now, we are mainly thinking for the Fabric integration. That's the main motto for us. Yeah. So yeah, I will explain you the approach that we have designed for BiniBFT. Uh, in blockchain, we used to have a number of nodes. Let's assume in HLF, I will explain you in terms of HLF. There are a number of peers will be there. Let's assume there are a number of orders will be there. Let's take an example of orderer nodes. Let's assume there are 4 to 5 orders are there. Now in Smart BFT, how it happens? Let's give an example how Smart BFT works so that we can compare with BiniBFT for as an example which has been integrated into 3.2 of Fabric. In Smart BFT, how it happens is as it's one of the Byzantine fault tolerance consensus algorithm, which is fabulous. In Smart BFT, whenever a transaction comes, it will get gone to. It usually goes to the leader, and leader will propose that particular transaction or a block of transactions to a prepare phase, and commit phase, which will a leader will communicate with the all the nodes. So basically, a block will the leader need to communicate with the rest of the nodes. Let's assume if you have 5 nodes, let's assume third person is the leader. The rest of 1, 2, 4, and 5 need to have a communication with the leader to get that particular block and need to do all the phases. Let's assume prepare phase, and commit phase. Then if they comes into an agreement, let's assume a quorum based will be there. Basically a system can able this Smart BFT can able to tolerate until 2f plus 1. Basically it can able to tolerate f plus 1, basically 2f plus 1 fault nodes in a network. So here every node need to go through this prepare phase and commit phase. Once the leader got that commit phase response, then only we used to update the ledger. Basically we used to call that commit function, which will probably send that particular block to the peer. Basically a peer will be listening for a particular channel. The order will push that particular block to the peer. The peer will use for the next of the validation. This is the thing that usually happens in the Smart BFT. Now, when comes to BiniBFT, the approach that we have gone through is that, so we have used a term called sharding. So we might have, most of the people have an idea about sharding. So we have designed in a such a way that we are going to design it in a such a way that let's assume there are 100 nodes in a network, and we have splitted that into 10 shards. Let's assume we have designed that we have splitted that into 10 equal shards. So each shard will consist of 10 nodes, right? So in each node, one person will be the leader. So basically, there will happen an election between inside that shard itself, and one person will be elected as a leader. So now we have 10 leaders from the whole network. This is the approach for the leader. Now, from that leaders, we used to select a leader, a random verifiable function. We are using VRF for selecting one person as a leader, main leader, where this is the person who is to propose the particular block. So now, instead of sending it to every node, now the person who is got selected, a sharded leader, the main sharded leader from about 10, we have selected one person as a main leader, where he is the person who is to propose that particular block, but not to the every node in the network, but only to the shard members, basically shard leaders. So the main, let's assume in the node 3 has been selected as a shard leader, then it will send that particular block into uh, shard 1, shard 2, shard 4, and shard 5. So each shard will consist of again some n number of nodes. Let's assume, as per our example, we have 100 nodes. In that 100 nodes, we have 10 leaders, and we have selected one person as the main leader. So now let's assume we have selected node shard 3 as the main leader, shard 3 person as the main leader. Then he is the person who used to propose that particular block. And now let me explain. I hope you got this sharding thing. Now I will explain you how the transaction flow happens in HLF with respect to BiniBFT. Whenever a client request has been initiated, it will come to a request pool which has been there along with the orderer, where the request will get accumulated into the request pool, nothing but accumulated, where it will get accumulated over there. And I hope everyone knows about there is a batch timeout. So basically, size and batch timeout will be there. Batch size and batch timeout, which usually there in HLF. So we are making use of these two things, and where every batch timeout or batch size has been happened. So we'll get the block from the request pool. We'll make that block formation with a validation, and we'll call that particular leader. In our example, we have node 3 as an example. I mean, node 3 as the sharded leader. Node 3 as the sharded leader. Now we'll propose that particular block to the node 3. Now node 3 will send that particular block which has been proposed. So basically the node 3, the sharded 3 block will send that to the shard 1, shard 2, shard 4, and shard 5. Now again in the node, so let's assume if you are thinking of a node 1 which is nothing but a shard 1. In shard 1 we used to have 10 nodes. As for our example of 100 nodes, we have 10 nodes again. So now that main leader will send that to the internal followers. Now internal followers will get receive that particular block. They used to validate as per the message, I mean phases that has been there in PBFT and smart BFT. So every node, every shard leader will send that to the respective shard followers. So in case of here node, shard 1 will send it to the rest of the followers. Shard 2 also will send it to the respective followers. Shard 4 will send it to respective followers, and shard 5 usually does that same thing. Once shard 3 receives 2f plus 1 as a response after doing all this prepare phase, and commit phase. Once this shard leader got that 2f plus 1 responses from the shard persons, here we are only asking a response from 4 shards in this example. When comes to our 100 nodes example, we are expecting any response from 2f plus 1 from the 10 shard nodes. Okay. So once a shard leader receives that response, 12 plus responses, so then we used to call for the update of the ledger. So this is the flow that usually happens in BiniBFT. Let's have a comparison with smart BFT. So in smart BFT, how it happen, if a client request comes, it will get accumulated and a block formation will happen. But a main leader who has been elected need to send it to the every node in the network. Let's assume there are 100 nodes. It need to send it to 100 nodes. So there is a message propagation will be there. There is a network congestion will be there. Why? Because it need to communicate with all the nodes in the network. Now, once a main leader receives 2f plus 1 responses from the 100 nodes, by doing all the phases, let's assume a prepare phase, and commit phase, it will update that ledger. So this is the flow that usually happens in smart BFT. But in our case, we are assuming and we are thinking the way approach, designed approach, that we will split that. Then 100 nodes has been split into 10 equal shards. And equal shards will consist of, each shard will consist of one main leader. The main leader will take care of the communication between the followers instead of a main leader doing that. Here, the shard leader who has been elected will be the primary leader, and for every shard, there will be one secondary leader who usually have a communication with the followers. So this is the approach that has been designed for BiniBFT, that approach that we are gonna do. And this is a sample code example that visually we are gonna design. So I will explain you how this leader election from shards usually happens. Let's assume there are nodes, 100 nodes. As an example, we took there are 100 nodes in the network. We will shuffle the nodes. Okay. So here the example here is the pseudocode that you are seeing over here is for this selection of the sharded leader, the primary leader. So here we have 100 nodes and we have selected 10 nodes, and in a 10 nodes we are selecting one person, right? One person as a main leader. So that main leader will usually follows the flow that you are seeing over here, the sample pseudocode, which is visible for you guys. So that we have divided the nodes into shards, and each node in the shuffle nodes and assigned end to the shards. And basically this is a sharding example, so that we're gonna design. So where we usually split that 100 nodes into equal shards according to the network. So we'll split without any problem in the network itself. Uh, and we'll select a main primary leader and the secondary leader within the shard. So this is the best sample pseudocode that you are seeing over the screen. And when it comes to the request handling flow, so here you can see the flow of this one. So this is the sample code over here, where the request handle, where the request comes, how the request gets submitted by the external client, and how the request comes and how it's get accumulated. Once the verification is added, it will get added into the accumulator pool. If the size, batch size, or timeout rates, we used to extract the particular request, and we have selected. Basically, I already told you we are selecting a leader with using VRF, verifiable random function. We are selecting a one leader from the 10 shard leaders based on some metrics that we are yet to design. So based on some metrics, we are selecting a one person as a main primary leader, and we'll propose that particular block to the person. So this is an example of that. And what comes next? So here we are here, I mean, the previous version has some architectural changes. Now we have designed a pseudocode and architectural flow that we are thinking it can able to scale at most, and we are anticipating it can. So now we want to make the pseudocode into an actual code. So basically the consensus algorithm need to be designed like of a smart BFT has been there. So we need to design that particular BiniBFT consensus library into from pseudocode to the actual code. Then we need to integrate it as per the fabric architecture. So basically we used to have peers and order concepts in HLF. So we need to have, whenever a block comes, so the ordering usually happens in order, as you guys know. So basically the ordering how happens, and where we need to include this particular consensus algorithm like of smart BFT, and how this architecture should wind. So basically how we can able to link this particular consensus algorithm with existing fabric code. So this is the integration that we need to work on after development of this actual actual code from pseudocode. And the enhancements, once the design and architecture implementation is done, then we need to work on the implement of improvising this particular thing on scalability, and increasing how we can able to make system more resilient, and so on for the throughput. So along with this, we are also using this in smart BFT. There is a concept of use. Basically, if a leader goes down, so then let's assume here in the shard of 10 nodes, there are 10 followers are there in a particular node. Let's assume the main leader who is in that particular shard. Let's assume we are considering shard 1 as a main leader. If a leader node goes down, then the followers need to have a re-election with the help of a V concept that we are thinking. We may go with epoch or else view, which is already there in epoch, will be there in BFT, and this view concept is there in smart BFT that we are thinking of the phase of that. So if a leader goes down, how we can able to alter that, and the re-election need to happen without stopping the transaction flows. as well as if if a main person, a primary leader goes down, how we can able to select the next leader from rest of the sharded leaders. So that is one of the thing that we need to think of. Yeah, and these are my LinkedIn profiles and Anasuya's LinkedIn profile and GitHub profile and blog post. So here we are here, and we are encourage you guys. You can connect and let's explore if there is any problems, feedbacks that is there in BiniBFT that we can able to improvise for the Hyperledger Fabric architecture, or is there any what you call suggestions that we can able to add upon, or technology that we can able to include it into this BiniBFT consensus, which can scale more than the architecture that we have designed. We are open to connect, and we are ready to know more from you guys. Yep. Thank you, everyone. Thanks for Anasuya for selecting me as mentee. Along with that, thanks for Linux Foundation. So Decentralized Trust. Thank you NPCI for cooperating and guiding me for doing this particular project. Yeah. I'm open for the questions. I'm open for the questions, so let's have a discussion, or else.
Thank you, everyone. Actually, for patiently listening. And Raju, we have few questions in the chat box. We can
Yep.
scroll it and check it out.
Okay. So how does a BiniBFT identifies a malicious node? So we can see an example. Let's take an example of Smart BFT. If you are making a transaction, if the value, let's assume we are thinking of a sequence number. So for every block, we used to have one sequence number. And if a person tried to manipulate that particular sequence number, and the sequence number that is available with the rest of the nodes is not equals to the person that you are doing. Let's assume a malicious node is making that sequence number also hash with a different one. Then we'll consider that particular node as a malicious node, and we assume that this is the malicious node, so we'll exclude that and we'll continue for the rest. There will be a chance, that it's not be malicious, but there is a chance there is also network delay that will also be there. So we need to conclude that based upon if it's doing frequently, then we need to have a call on it. If not, we'll continue for the rest. So that is the main, that how we usually find out this malicious node, like of a smart BFT itself.
That makes sense, Raju. Thank you. It was
Yep.
me who asked this question.
Oh, thank you, sir.
Yeah, no, this is great. Thank you for the work, by the way. This is fantastic,
Thank you.
guys. You put together. It's going to be
Thank you.
helpful
Yep.
in many ways. Someone asked a question about when do you expect this to be included as part of?
Yeah.
Yeah. So
Yeah, so we are open for the open-minded people. Basically, we are expecting some more developers to join as a team for collaboration and for the new ideas too. Maybe Ansuya will answer you more clearly. I think so.
So
Take
actually,
his
this
take on
is
it.
our wish, and we wish to see this as probably in Fabric 3.5. So we wish to hopefully now 3.0 itself is a good one.
Yep.
And to be frank, 3.0 got released uh, years after we started working on. And of course, the Smart BFT people would have also been working for at least for 5 years, they would have worked on, I believe so. So let's see,
Yeah.
now we
So
have to
adding.
integrate it. After integrating, we will be able to answer your question very clearly.
Yeah.
We hope
yeah,
and we
totally.
strongly believe that it will have a better scalability.
Yep.
Yeah.
So we are
And
open for
on the
feedbacks, sessions too.
similar aspect, just a follow to the question. Do you foresee BiniBFT and Raft working hand in hand together in conjunction, or is it a complete replacement of Raft?
So we are thinking of a replacement of Raft.
Okay.
So if there is a need of that, then we'll take a call on it. So presently we are thinking to, and as a replacement basically. So if you make it as a BFT also, it can able to tolerate the crashes too. So which is as usually Raft usually doing the crash fault tolerance. So we will make this a system where it can able to tolerate both. So where it can able to tolerate Byzantine fault tolerance and crash fault tolerance if a node goes down. How the mechanism that we are yet to work. I mean, we are working on it. So how a mechanism that we can able to make the rest of the nodes to do that particular flow of transaction happens without any delay. So we are working on it. So mostly it will be not a replacement. Along with, we can think of it as an along with. So yeah, and there is a huge need for what you call consensus. Why? Because as you know, NPCI also has been working on CBDC, the central bank digital currency, which is built upon HLF. So there is a huge need of BFT basically. So there will be a huge chance we'll deliver it as early as possible. Yeah, I hope you got my answer.
I
Like,
did. Thank you, Raju.
Thank
And
you.
that make all of that makes sense a lot.
Yep.
Thank you
Yeah.
so much. I had to drop, but it was great. I look forward to the recording.
Thank
Thank
you.
you.
Thank you.
thank you for attending.
So can
Of
you
course.
expect it to be incorporated with Bevel operator any soon? Uh, Not sure exactly. So we firstly wanna design this consensus algorithm. Later on, we'll think of this Bevel operator. So firstly, we want to get that particular pseudocode that we have come up into a particular what call a big consensus algorithm like a smart BFT. Once we see any difference, then we'll think of the implementation into the Bevel operator. That's for sure if it's needed. So if there is a huge user base is working on it, we'll definitely will integrate into that. And what's the minimum number of nodes are required for better battle tested consensus with BiniBFT? That are yet to test. So that is yet to test. So that is not yet decided. We'll definitely will work with both small number of nodes with a minimum number of nodes and high number of nodes. So we'll tackle both situations. There is work going on around, so we'll let you know about these things also. I mean, you can have a look over the blogs what you call BiniBFT page, where we'll be posting details regarding to this in future too. I hope you answered that question.
And you can share the blog post also, right? Like,
Yeah, it's all at them, ma'am.
can, or I can also share that.
Yeah, please.
I got the link.
Yep.
So if you want to like share it on the screen, you can show it once.
Yeah, I hope it's visible.
So here, like, you can directly get to the uh,
Paper.
white paper 2, version 2. That is the
Yeah, yeah.
current
So it's
one.
already open.
Yeah.
So this is the paper, the approach that we were working with. So a white paper approach that has been architectural design has been changed from the earlier version. So the version that have been introduced right now. So this is the version that we are working on. So there will be some more changes for sure. So but we'll stick to the mechanism that has been designed for now. So but the flows and tech stack, underlying tech stack will get changed. Mostly we'll design the whole architecture on Golang as smart BFT itself, as mainly Hyperledger is on Golang. So we'll build this consensus algorithm on Golang itself. And this is just different pseudocodes of different functionalities, prepare phase, and commit phase, and how these heartbeats happens, and what is the view change process, and the rest. So this is a white paper, and there will be new upcoming features that being get added. For now, yeah. To test it out, do we have resources maybe similar to fabric samples? We will incorporate with HLF itself. So we can make use of fabric samples itself. There is no need to have extra resource. So it's, I mean, we can simply say that it's a normal a consensus algorithm which comes along with the orderer itself. Once you got that orderer, normally how you are running fabric right away, which comes, let's assume if you're running 2.7, which have the raft as a consensus, the same way we'll get this BiniBFT which get incorporated into HLF, Hyperledger Fabric, in the order as in a consensus library, where we can make use of same fabric samples which already existed, will be used for sake of running or testing it out. That's for sure. Hope everyone got the thing. I mean, looking forward to connect with you guys over LinkedIn. This is my LinkedIn page, so you can connect, and this is the GitHub and blog post, and Anasuya's LinkedIn also is available over here. You guys can get connected over the LinkedIn, and we have a chat regarding different tech stack of blockchains, and main, if needed, we can connect over the BiniBFT implementation and architectural things also. So I'm open to that. Can you please share social or LinkedIn links here? Sure. One sec. Ma'am, can you please share?
Yeah.
Yeah.
I have shared mine. Raju, should I share yours?
Yep. Share mine to ma'am.
Okay, I will share. Give me a sec. So here is Raju's LinkedIn ID. Thank you, Alfonso.
Yeah. Thank you, Alfonso.
So David, I believe there are no questions in the YouTube also, right? I was
I
checking
didn't
out
see
on the
any.
side.
Yeah, I didn't see any questions over there. So
Yes.
if we don't have any other questions, I guess we can wrap it up. So thank you everyone for
Thank you.
joining, and thank you, Raju, for presenting. And again, I'll send an email out with these resources to everyone who signed up.
Cool.
All right. Thanks, everyone.
Thank you.
Thank you, everyone. Thank you.
Thank you.
Bye.
David.